Ask 10 people on the street if a human being can turn into a black hole. 9 of them will smile and say, "Of course not." They're wrong. What about a rock, a bucket of water, or that loud chihuahua barking at the delivery driver? If you ask modern physics, yes, and absolutely yes. Most people think a black hole is a specific thing, a giant cosmic monster created only when massive stars die. But in physics, a black hole isn't an object, it's a state of matter. Here is the fundamental rule of our universe. Take any mass, compress it into a small enough volume, and gravity wins forever. The escape velocity becomes higher than the speed of light, and once light can't escape, the universe closes the curtains. You have a black hole. So, how small are we talking? Take an average 210-pound human. How small do you think you'd have to squeeze them? The size of a basketball? A golf ball? A grain of sand? Your brain naturally wants to pick a size you can picture, but the math doesn't care about what we can picture. To turn a Holland into a black hole, you have to compress them down to 10 to the power of minus 25 meters. That is 10 billion times smaller than a single proton. Is it physically possible with today's technology? Absolutely not. But mathematically, the calculation is flawless. So humans work in theory. What about something bigger? What about planet Earth? Could our entire planet become a black hole? Ask yourself right now, how small would Earth have to get? A house? A football stadium? No, a marble, a 9mm sphere. Now, here is where everyone's intuition goes completely off the rails. Imagine having that marble-sized Earth sitting right in front of you on a table. What do you think it would actually do? Would it instantly vacuum your room into a roaring vortex? No. Would it pull you across the floor and swallow you whole? No. Would it detonate like a nuclear bomb? No. If you stood just 10 feet away from that marble-sized Earth, you would feel the exact same gravity you feel right now standing on Earth. If you replaced our planet with a 9mm black hole of the exact same weight, you wouldn't get sucked in. You would just be standing there in the dark, floating peacefully at 1 g. Why? Because gravity doesn't care about size. It only cares about mass and distance. The black hole doesn't suck things in from a distance like a vacuum cleaner. The nightmare only happens if you touch it, because all of Earth's mass is packed into a point smaller than your fingernail. Get within an inch of it, and the tidal forces will rip your hand apart at the atomic level. It's not a vacuum, it's a gravitational razor blade. So, Earth can become a black hole. But that brings us to our next question. If you manage to create a tiny black hole, could you keep it? Could you put it in a lab and study it? Most people think, well, it's a black hole, it's indestructible, it'll last forever. Wrong again, and trying to keep one would be the last mistake humanity ever made. To understand why, you have to understand the 3 terrifying rules of Hawking radiation. Rule number 1. Small black holes leak. Quantum effects near the event horizon cause black holes to slowly bleed energy back into space. They lose mass over time. Rule number 2. The smaller they get, the hotter they burn. As a black hole loses mass, its temperature skyrockets, making it evaporate faster and faster. Rule number 3. The smaller they are, the more violently they explode. Let's look at what that actually means in reality. If you compressed a 210-pound human into a black hole, it wouldn't sit there quietly. It evaporates in 73 trillionths of a second, converting all its mass into a blinding flash of energy, releasing more than 40 times the energy of the Tsar Bomba, the largest nuclear explosion ever detonated. What about a loaded 40-ton semi-truck? It lasts about 5 milliseconds. But when it goes, the explosion would release hundreds of gigatons of energy, far exceeding the combined yield of the world's entire nuclear arsenal. And a massive naval supercarrier? It lasts longer, about 2.7 years. It seems stable, but when its final millisecond hits, the energy released would approach the scale of a major asteroid impact, with consequences on a continental or even global scale. To put it simply, tiny black holes are just as volatile and explosive as your ex. Okay, so small black holes explode. But what if we go bigger? What if we talk about whole worlds? Imagine tomorrow morning, Earth instantly collapses into that 9mm marble black hole. What happens to the moon? Take a guess. Does it crash into us? Does it fly away into deep space? Nothing happens to the moon. The moon would continue orbiting the exact same empty spot in space, on the exact same trajectory, at the exact same speed for billions of years. Why? Because the moon merely plays along, pretending to be captivated by Earth's bottomless blue oceans, sculpted peaks, and dense, beautiful forests. At the end of the day, all she really wants is Earth's gravitational payout. And as long as that mass stays the same, the moon couldn't care less whether Earth is a thriving blue world or a terrifying purple-black marble. That says a lot about you, moon. Which leads us to the biggest object in our sky, our sun. Can the sun become a black hole? You'd think the answer is an obvious yes. It's huge, it's heavy. Ironically, the sun isn't heavy enough. Our sun can light up the solar system for 10 billion years, but when it dies, it simply doesn't have enough mass to overcome atomic pressure. It will end its life as a quiet white dwarf. But what if an advanced alien race compressed the sun today? Its event horizon would be just 3.6 miles across, roughly the size of central London. Imagine parking a city-sized black hole where the sun is right now. Every planet stays in orbit. Earth doesn't get sucked in. The seasons stay identical, except the light goes out. Solar radiation drops to zero. Within weeks, the oceans freeze solid, and Earth becomes a frozen ice world, orbiting a 3.6-mile invisible shadow. So, if humans, trucks, Earth, and even our sun cannot turn into black holes on their own, what actually does? Nature has a strict cosmic flaw. Stars lighter than about 3 suns simply cannot form black holes when they die. Their internal nuclear pressure wins. You need a massive heavyweight star to die and crush itself under its own weight. When a star with 3 solar masses finally collapses, the black hole it creates has a radius of about 5.5 miles. Think about that scale. Its height is sitting right between Mount Everest and Olympus Mons on Mars. Nature has one absolute rule. To join the stellar black hole club, you have to be at least as big as Mount Everest. Or Donald Trump's ego.
I feel really, really strong.
So, where is the closest one to Earth right now? The closest one we've discovered is Gaia BH1, located about 1,560 light-years away. It packs nearly 10 solar masses into a sphere smaller than the Tokyo metro area. It's sitting out there in the total blackness of space. Perfectly silent, completely harmless, just drifting. Now, let's break the scales entirely. What happens when black holes stop playing small and start eating whole galaxies? At the center of our Milky Way sits Sagittarius A star, a supermassive black hole weighing 4.3 million suns. You'd expect a monster ruling 100 billion stars to be staggering in size, right? If you placed Sagittarius A star in the center of our solar system, it wouldn't even reach the orbit of Mercury. The supreme ruler of our entire galaxy fits comfortably inside the innermost planet's orbit. If you want a real nightmare, meet M87 star, the icon from the famous first-ever direct black hole photo. M87 star weighs 6.5 billion suns. If you put M87 star where our sun is right now, it swallows Mercury, it swallows Venus, Earth and Mars, it swallows Jupiter, Saturn, Uranus and Neptune. Even Pluto, orbiting 3.7 billion miles away in the frozen dark, gets gulped down effortlessly. M87 star extends 3 times further than Pluto's orbit. A horrific sight, but who in the solar system could survive? Voyager 1, launched by NASA in 1977, is currently drifting over 15 billion miles away in interstellar space. If M87 star appeared today and consumed our solar system, Voyager 1 would sit just outside its event horizon, unharmed in the dark, carrying greetings on its golden record from a civilization that no longer exists. Is M87 star the limit? Can a black hole get even bigger? Oh, absolutely. But here is where numbers stop making sense and space itself breaks. Meet Ton 618, a cosmic titan weighing 66 billion suns. And modern surveys up to 2026 suggest giants like Phoenix A star could reach an astounding 100 billion solar masses. At this scale, comparing sizes doesn't work anymore. You have to look at what it does to reality. If you place Ton 618 where our sun is right now, it wouldn't just swallow Earth or Pluto. it would swallow our entire solar system and still have room inside its shadow for dozens more. Light travels at 186,000 miles per second. It crosses our entire solar system in 11 hours. To cross Ton 618 from edge to edge, light has to travel for 2 full weeks. In other words, the diameter of Ton 618 is large enough to accommodate our solar system 32 times. We started with a human being, a truck, a marble-sized Earth, and we ended with a void so impossibly large that light itself gets tired crossing it. Every black hole in existence, from Phoenix a star all the way down to a theoretical marble-sized Earth, obeys exactly the same simple law. Compress enough matter into a small enough space, and the universe stops caring what it used to be. It doesn't care if you are a star, a planet, or a human. Sounds like science fiction, but it's real physics. And before Holland collapses into a black hole, you've got plenty of time to smash that like button, subscribe to the channel, and leave a comment. Stay curious, and see you in the next video.